Hello everyone. Welcome back to the second episode of our complete AWS ECR video series. In our previous video, we dived into the core concepts of AWS ECR, exploring what ECR is, and why it plays such a crucial role in container management. We also covered the different types of ECR repositories, key features and performance, and even looked at some real-world scenarios to see how it all comes together. If you haven't had a chance to watch that episode yet, I highly recommend starting there first to build a solid foundation. Check the link in the description below. So, in this video, we'll be exploring the ECR Image Lifecycle, and doing a hands-on demo to see exactly how container images move through their lifecycle in practice. When working with containers, the image lifecycle usually follows a clear path made up of 5 essential stages. These stages define how an image is created, managed, and eventually retired. The first step is build. This step involves creating your Docker image by packaging your application along with its dependencies and configuration into a single, portable image. The image can be built locally or in a CI/CD environment, depending on your workflow. Think of it as preparing a self-contained, ready-to-run snapshot of your app. Next comes push, where you upload the image to an ECR repository, making it accessible in the cloud for other services or team members. You can think of this as sending your packaged application to a central storage location, so it can be shared and deployed as needed. The third step is store. Amazon ECR securely stores your image, handles versioning with tags, enforces access controls, and optionally applies lifecycle policies to automatically clean up old images. This step ensures that your images are organized, safe, and easy to retrieve whenever required. After that, we have pull, which is when you retrieve the image from ECR to run it on a server or local machine. Services like ECS, EKS, or a local Docker host will pull the image whenever a container needs to be launched, ensuring that the correct version of your application is always available where it's needed. Finally, the last step is delete. Removing an image from the repository helps free up storage space and keeps your repository clean. This step is essential for maintaining efficient storage usage and preventing outdated or unused images from cluttering your registry. Now that we understand the ECR image lifecycle, let's put it into practice. In this hands-on section, we'll walk through the process step by step. We'll begin by creating a simple Docker image on our local machine. This essentially packages our application into a self-contained image that we can later push to ECR. For this demo, we'll use Kalima to run Docker locally. Next, we'll set up a new repository in ECR to store our Docker images in the cloud. We'll do this in 2 ways, first using the AWS CLI in the terminal, and then from the AWS console, so you'll see both approaches. Before we can push anything, we need to log into our ECR registry with the AWS CLI. This ensures our Docker client is properly connected and ready to push images securely. With authentication complete, we'll push our locally built image into the ECR repository. This uploads the image to the cloud. Once the image is in the cloud, we'll pull it back down to the local machine. This demonstrates how images stored in ECR can be retrieved for use on servers or container platforms. After verifying everything works, we'll delete the image from the repository. This keeps things clean and avoids leaving behind unnecessary images. Finally, we'll wrap up by deleting the repository itself. This frees up resources and neatly closes the loop on our hands-on demo. Now that we know all the steps we need to follow, it's time to move into the hands-on part. Alright, before we jump into the hands-on part, I've created a brand new GitHub repository dedicated to this ECR video series. You'll find the link to this repository in the description below, so it's easy to access whenever you need it. For today's video, we'll be working with a specific branch called ecr-basics. Check out this branch to follow along step by step. To make things easier for you, I've already included all the necessary commands and reference links inside the README file. So before we dive into the ECR Image Lifecycle hands-on part, we need to get our local environment ready. Since I'm on a Mac, I'll be walking you through the process of moving an ECR image through its lifecycle using macOS. The very first step is installing Homebrew, often just called Brew. Now, if you're not familiar with it, Brew is basically a package manager for macOS. Think of it as a tool that makes it really easy to install, update, and manage software on your Mac without having to go through complicated manual steps. It's one of those essential tools that just saves a ton of time. To install it, you can simply copy and paste the command I've already included in the GitHub repository. I'll go ahead and run it here. Once the Brew installation is complete, the next step is to install Kalima. Now, you might be wondering, what is Kalima, and why do we need it? Kalima is a lightweight container runtime for macOS that gives us Linux-based containers without needing something like Docker Desktop. It's fast, open source, and works perfectly with Docker. Basically, it creates the Linux environment that Docker needs to run on Mac. With Kalima installed, the next step is to install Docker itself using Brew. Brew will handle everything for us, so it's just a simple command. Once Docker installation is successful, we'll go ahead and start Docker using Kalima. This will spin up the runtime in the background, so Docker can run properly. When the Docker runtime is up and running, we can verify it by checking the Docker version. That way, we know it's installed correctly and responding as expected. And as a final quick test, let's run the official Hello World Docker container. If we see the expected message, that means Docker is fully set up and working fine in our local environment. Now that Docker is up and running successfully on our local environment, let's move on to installing the AWS CLI version 2. The first step is to download the AWS CLI v2 package onto our machine. Once the package is downloaded, the next step is to install it. The installation is straightforward and should only take a few moments. After the installation completes, we can verify where the AWS CLI was installed by using the which command. This helps confirm that the CLI is properly linked in our system path. Finally, to double-check that everything worked, let's run the AWS version command. This will display the installed version of the AWS CLI and confirm that it's ready to use. So now that we have all the prerequisites set up in our local environment, let's move on to the next step. The first thing we'll do is clone the repository into our local machine and check out the correct branch. I've already opened the project in Visual Studio Code, so let's navigate into the project folder where the Docker file is located. With that in place, we can now start Dockerizing our Node.js monolith application. To do this, we'll use the docker build command, which will generate a Docker image based on the instructions defined inside the Docker file. Once the build process completes successfully, we can confirm the image creation by running the Docker images command. This will list all the Docker images currently available in your local environment. If you're starting fresh, just like me, you'll notice there are only two images listed, the default Hello World image, and the brand new image we just built, which is our Node monolith app. Now, let's take it a step further and run this Docker image. After the container starts, you can see that the image is running successfully, which means our application is now live inside a container. The final step here is to copy the application URL where the Node app is running, paste it into your browser, and verify everything is working. If all went as expected, you should now see the home page of our application displayed. Now we will be creating a dedicated IAM user for this video. This user will have access only to AWS ECR, and since the focus is just on ECR, I won't be going into too much detail about the IAM process itself. Start by navigating to the IAM console. Under the Users section, click on the Create User button to begin creating a new user. Provide a proper username for this account so it's clear that this user is meant specifically for ECR access. Next, enable AWS Console access by checking the Console Access checkbox. Under Confirmation Options, select the IAM User option since we are creating a brand new user here. For the console password, I will provide a custom password. Because this is only a demo setup, I won't enable the option that forces the user to create a new password at the next sign-in. Once that's done, click on the Next button. On the Permissions page, choose the option to attach policies directly. In the Permissions section, search for the Amazon EC2 Container Registry Full Access policy and select it. After that, click on the Next button again. You will now see a review screen with all the choices we made. Confirm that everything looks correct, then click on the Create User button to finish. Once the user has been created successfully, you'll be able to see the console sign-in details displayed on the screen. Next, we need to create an access key for this user. Now, what exactly is an access key? An access key is a pair of credentials consisting of an access key ID and a secret access key, and it's what we'll use to authenticate our IAM user when connecting to AWS from the AWS CLI. This allows us to securely interact with AWS services right from our terminal. To create one, let's head over to the Users section in the IAM console. From the list of users, click on the user we just created to open their details page. Once inside, navigate to the Security Credentials tab. Scroll down until you see the Access Keys section, and then click on the Create Access Key button. On the Create Access Key page, you'll be asked to select a use case. Since we'll be working from the command line, choose the option for Command Line Interface. After selecting the use case, check the confirmation box to acknowledge the warning. Then click Next to move on to the next step. Here, you'll be prompted to provide a description tag. This is optional, but it's good practice to add something descriptive, so you know what the key is used for later. Finally, click the Create Access Key button. This will generate a brand new access key for our IAM user, and once it's ready, you'll be able to download or copy the access key ID and secret access key. And that's it, we now have a fresh set of credentials that we'll configure in the AWS CLI. Alright, now we are going to configure the AWS CLI. For this, we will be using AWS configure command. So, what exactly does the AWS configure command do? It helps us link our local CLI to a specific AWS user account by storing the necessary credentials and settings. Open your terminal and type the command AWS configure, then press Enter. The CLI will first prompt you for the AWS access key. Head over to the AWS console, copy the access key we created for our new user, and paste it here. Next, it will ask for the AWS secret access key. Once again, go back to the AWS console, copy the secret key, and paste it into the terminal. After that, it will prompt for the default region name. For this setup, I'll provide US East 1. Then it will ask for the default output format. We'll leave that blank for now, which means it will default to none. Once the configuration is complete, a hidden folder named .aws will be created automatically in our local machine. To confirm this, navigate to your home directory and open the AWS folder. Inside, you should see two files, config and credentials. If these files exist, it means our AWS CLI configuration was successful. Now, let's verify that everything is working as expected. Run the AWS command to list all repositories. Since we haven't created any repositories yet, you should receive a success response, but the list will be empty. This confirms that the configuration is set up and functioning properly. Next, we need to log into the AWS Management Console using the newly created IAM user. Once logged in, navigate to the ECR console. From the sidebar menu, click on Repositories. Since I previously set the default region to US East 1, I'll switch the region here to match that setting. As you can see, there are currently no repositories created in this account. This also confirms that our AWS CLI configuration was successful and is working properly. We've already set up all the prerequisites for moving a Docker image through its lifecycle within ECR, so now let's move on to the next steps. The very first step in this process, creating a Docker image locally, we've already completed. The next step is to create an image repository in ECR. Let's go ahead and do that. I'll copy and paste the required AWS CLI command to create the repository. Since I didn't specify any region in the command, the repository will be created in our default AWS region. After running the command, you can see the success response from AWS confirming that the repository was created successfully. To verify this, let's head back to the ECR console as the newly created IAM user. Refresh the repositories, and as you can see, the new repository has been created successfully in AWS. Next, I'm going to show you how to perform the same step, creating an ECR repository, but this time directly from the AWS Management Console. This way, you'll see how it can be done visually in addition to using the CLI. Once you're inside the ECR console, navigate to the Repositories section and click on the Create Repository button. This will take you to the Create Repository page. The first thing you'll need to do is provide a clear and descriptive name for your repository. This is important because it helps you easily identify the repository later. Next, you'll see the Image Tag Settings section. This allows you to control whether repository tags can be overwritten after pushing. This setting applies to all repositories created in Amazon ECR. Inside the Image Tag Settings, you'll notice an option called Image Tag Mutability. Now, what exactly is Image Tag Mutability? Essentially, it defines whether tags in your repository can be overwritten. There are two types of tag mutability, mutable and immutable. Mutable enables image tags to be overwritten. This is recommended for repositories using pull-through cache actions because it ensures Amazon ECR can update cached images. Immutable prevents image tags from being overwritten. Once an image is pushed with a tag, it cannot be replaced. This setting applies to all tags and exclusions in the repository. There's also something called mutable tag exclusion, which allows you to exclude certain tags from being immutable. For this demo, I'll leave the defaults as they are under the image tag settings. Moving on to encryption settings, this determines how the data in your repository will be encrypted at rest. You have two options here, AES 256 and AWS KMS. With AES 256, Amazon ECR uses server-side encryption with Amazon S3 managed encryption keys, applying the AES 256 algorithm. This comes at no additional cost. With AWS KMS, ECR uses server-side encryption with AWS Key Management Service. Here, you can either use the default AWS managed key or specify your own customer managed key for more control. For this demo, I'll also leave the encryption settings at their default values. Next, we have image scanning settings. This option used to allow image scans to be enabled at the repository level, but it's now deprecated. Today, image scanning is managed at the registry level with repository filtering. So again, I'll leave this setting as it is. With all these configurations in place, let's go ahead and create our repository. Once the process completes, you'll see the new ECR repository created successfully in the console. Alright, let's switch back to our local terminal. Now we're moving on to the third step in the ECR Image Lifecycle, which is authentication to our ECR registry. I'll just copy and paste the login command from the GitHub repository. Once it runs successfully, you'll see a confirmation message printed right here in the terminal. The fourth step in the lifecycle is pushing our Docker image to the ECR repository. But before we do that, let's first list all of the Docker images that are available locally. As you can see, the Node Monolith app image we built earlier is right here. The next step is to tag this image using the repository URL that was generated when we created our ECR repository. So, what does image tagging mean, and why do we need to do it? Image tagging is simply giving a Docker image a label so it can be identified easily. By tagging it with the repository URL, we're telling Docker exactly where this image should live in AWS ECR. This is required before pushing because Docker needs to know the destination registry and repository. Once the image is tagged, let's list our local images again to verify. You'll now see a new entry with the repository URL attached to it. Now, is this a completely new image? Not really, it's essentially an alias or another reference to the same underlying image, but with a new tag pointing to the ECR repository. With tagging complete, let's go ahead and push this image. The very first time you push an image, it will take a little longer because Docker needs to upload all the layers to ECR. However, for subsequent pushes, Docker uses layer caching. That means only the updated or changed layers will be pushed, while the unchanged layers are already stored in ECR's cache. This makes future pushes much faster. Once the push is complete, let's jump back to the AWS console and head into the ECR service. From the sidebar, click on Repositories and select the repository we created earlier using the CLI. This is the one we just pushed our image into. And now you can see that the image has been successfully pushed into our repository. If you click into the image, you'll be able to see all of its details, things like the image tag, the image URI, and more metadata. Alright, let's go back to the terminal one more time. Now let's use the AWS CLI to list the Docker images inside our repository. As you can see, there's one image with the latest tag, which corresponds to the Docker image we just pushed. The next step in the process is to pull the Docker image from ECR back into our local environment. But before we do that, I'm going to remove the tag Docker image that we previously pushed. This way, the environment stays clean, and there's no confusion between the existing local image and the one we're about to pull down from the repository. So first, let's list the current Docker images on the system. As expected, we can still see the tagged image sitting there. Now I'll go ahead and remove it using the docker remove image command. Once that's done, let's list the images again. And as you can see, the tagged image has been completely removed from my local machine. Now, with a clean slate, let's pull the Docker image from our ECR repository. To make sure we're pulling the correct image, I'll head over to the ECR console, grab the exact image URI from the repository, and paste it into the command. After pressing Enter, Docker begins pulling the image from ECR. Once the process completes, you'll see a message confirming the download was successful. Let's verify this by running the Docker images command again. And there it is, the image we just pulled from ECR is now available locally on our machine. The next step in our lifecycle is to delete the image from the ECR repository. Back in the terminal, I'll paste in the AWS CLI command that deletes an image from ECR. After pressing Enter, you should see a confirmation message in the terminal, indicating that the image has been successfully removed from the repository. Now let's switch over to the ECR console to double-check. I'll refresh the images section inside the repository, and as you can see, the image we just deleted is no longer there. That confirms the deletion worked. Heading back to the terminal, let's run the AWS CLI command again to list all images inside this repository. And as expected, the output shows an empty list, meaning there are currently no images stored in this repository. The final step in our image lifecycle demo is to delete the repository itself using the terminal. First, let's list all the repositories currently in our ECR account. As you can see, there are 2 repositories present at the moment. I'll paste in the AWS CLI command to delete the repository we created earlier through the terminal. After pressing Enter, you should see a success response printed out, showing the details of the repository that was just deleted. Next, let's list the repositories once again. This time, you can see that only one repository remains, the one we created earlier via the ECR console. The repository we created through the terminal is now gone. Finally, let's confirm from the ECR console itself. I'll refresh the page, and sure enough, we see exactly one repository left. That confirms the deletion worked successfully. Alright, that's it for the ECR Image Lifecycle demo. I hope this video helped you clearly understand the basic steps of moving a Docker image through Amazon ECR, from building and pushing, all the way to pulling, deleting, and cleaning up repositories. And that brings us to the end of this video. In the next episode, we'll take things a step further by integrating ECR with ECS and deploying a Docker image directly into ECS. That's where you'll really see how ECR fits into real-world container workflows. Thank you for watching. If you found this video helpful, don't forget to leave a comment, and I'll see you in the next one.